All right. I welcome every one of us to another question on Math 101 assignment, and we have our problem statement on mathematical induction. So the question says, prove using mathematical induction summation of k n minus k ranging from k equals 1 to n, which is equals to n minus 1 n plus 1 over 6. So we go ahead with the problem. So we start by applying the inductive step. Now, the next thing we have is the inductive step. So, inductive step simply means that you are checking for all of the values of n in terms of integers. So, you put when n equals to 1, when n equals so you put when n equals 1, n equals to 2, n equals to 3 to check if the left hand side is the same thing as the right hand side. Now, it is not necessarily that you check for all of the values for n. You can stop at when n equals 1 as long as the left hand side is equals to the right hand side, right? Now, the symbol there is a summation symbol. So summation symbol implies that you are going to check for you are going to put anywhere you see n to be equals to 1. So we have anywhere you see n to be equals to 1, so you have 1 minus 1, k to be 1 minus 1, so everything gives you 0. So you check for the right hand side as well, so you can see 0 over 6, which is equals to 0. So it simply implies that the left hand side is equals to right hand side. So this is for the inductive step. So we go ahead to check for other values for when n equals to k and so on. Meanwhile, you can check for when n equals to 2, when n equals to 3, but you can decide to stop when n equals to 1. Now, the next thing is to check if for when n is equals to m, and you might be wondering why we stated when n equals to m. Now, initially, normally you know that the next step is when n equals to k, but if you check through the mathematical induction question, you notice that we already have a variable named k already, so it doesn't make any sense to start with when n equals to k any longer. So you can use a different variable of your choice. So in this case now we are using m. So we are saying that when n equals to m, so anywhere we see m, we are representing it. Anywhere we see n, we are representing it with what? M. So that's the next step. So we are checking for the next one now when n equals to m plus 1. Now I want you to pay rapt attention to this other part. Now we are saying when n equals to m plus 1. Now you have to pay full attention to this. Now anywhere you see n now, you represent it with m plus 1. That's why you see that at the top of the summation sign, initially what we have there was m. Now it is now m plus 1. Are you getting it? Now similarly, by looking at the left hand side, what we change all of the n variable to m plus 1, and we do expansion. We change all of the n variable to m plus 1, and we expanded the sum. Now we expanded the sum in the sense that if you check very well, you notice that we expanded n to be m plus 1. Now there is the value for k. When we expand, it is a sum, is a summation symbol. Now whenever you are expanding a summation symbol, you expand, we write the first term and the last term. So the last term is the sum is starting from when k equals to 1 to when k equals to m plus 1. So we are now moving from when k equals to m to when k equals to m plus 1. So that was why you see at the first part you have k open bracket m plus 1 minus k plus m plus 1 multiplied by m plus 1 minus open bracket m plus 1. All the bracket is closed. So we expanded the value for k2. So we expanded the summation symbol by introducing k to be k equals to m plus 1 as well. Now at the other end, if you check the other end, you notice that m plus 1 minus m plus 1 will give you 0. So we are left with summation of k m plus 1 minus k. Are you getting it? So most of us that probably might be confused at the first line. The first line is what we did in the first line is that we expanded the sum, the first term and the last term. The last term is we look for a way to take away the m plus 1 at the summation sign. So the m plus 1 there, you see now that we no longer have m plus 1. What we have there is what is m. So we expanded, then we expanded the sum. Expanding the sum means that you are putting the value on top back into the summation itself. So that is why you see that we represented the k to be m plus 1 as well by expansion. So when we expanded, the top summation sign, which is meant to be m plus 1, the value at the top of the summation sign, which is meant to be m plus 1, is no longer m plus 1. It is now m. So we have that for the first line. So coming back to this, when you simplify the first line, we have what we have in the second line as well. Now the second line, you see that there is a summation symbol and k value. Now we expanded the summation symbol and the k value. We use it to open the bracket and we have two different sum. Now by having two different sum, you need to know for mathematical induction, whenever you see summation of k, automatically you know that summation of k is n open bracket n plus 1 over 2. So the n plus 1 over 2, you can use m plus 1 over 2, k plus 1 over 2, p plus 1 over 2. So that's what we mean by the representation, mathematical representation for summation of k. So it is not necessarily summation of k. It can even be summation of n. So if it is summation of n, it can be n open bracket n plus 1 over 2. And for the left hand side too, that one was given in the question initially. That was the question given to us already. If you go back to the question was kn minus k, and which is equals to n minus 1 n plus 1 over 6. So by comparing what we have in the question, you see we have these two expressions. So we can now go ahead and solve using LCM to simplify that expression. So the next thing is we solve using LCM, right? So our LCM is 6. So when we simplify further, we have m plus 1 m plus 2 divided by 6. Are you getting it? Now remember that we stated earlier that n is equals to m plus 1, right? So anywhere we are going to make n, anywhere you see m now, m is m plus 1. So we will be having m plus 1, m plus 2, and m. We have m plus 1, m plus 2 when n equals to m plus 1. Now we can make m the subject of the formula such that we'll go back to the initial question that was given to us. So when you make m the subject of the formula, m will be equals to n minus 1. Then we'll substitute it back to the initial question, and you see that the mathematical induction question holds. So when you make m the subject of the formula, m will be n minus 1, and when you substitute it back, you have that the mathematical expression question is what is correct, which means that the left hand side is equals to right hand side. Thank you.